Good morning, everyone. Let's get started. All right. So today we'll start with block and block. Before we do block and block, we'll just complete a problem which we were discussing, but similar to that. This block is M naught. This block is M naught. Coefficient of friction is mu. All right. I have to determine the acceleration of the blocks. Do I do it? This goes with an acceleration A naught or A. This comes down with an acceleration A, right? Because the constraint equation is if this comes down by x, this goes towards right by x. Right. Now, so net external force on this block is M naught G. Supporting force is M naught G minus mu M naught G is equal to M naught into 2 M naught into A. M naught gets cancelled out and have A is equal to G by 2 times 1 minus mu. I'll get the acceleration of the blocks. Do you all understand this equation, students? M naught G is supporting force minus opposing force is equal to total mass into acceleration. All right. I cannot say net force on this is M naught G minus mu mg. All right. But I'm presuming this to be hypothetically treating this to be horizontal, wherein I've got force towards right as m naught g, force towards left as mu m naught g. So mu is mu naught. If mu is less than 1, this will definitely start moving towards right. All right. So that's what the acceleration says. But if mu is greater than 1, my friction will self-adjust so as to counterbalance m naught g, and friction will be mg, m naught g. So do you understand this equation, students? See, acceleration is positive if mu is less than 1. That's what I get. But if mu is greater than 1, I cannot say acceleration is negative. The block doesn't go backward. All right, the block doesn't start moving towards left. If at all it starts moving towards left, friction will flip, and I'll have friction and this one has opposing forces. That's not possible. I mean, you cannot have without any force or velocity. This block cannot go towards left. If it all it has to go towards left on its own, it has to have some velocity or some other force acting on it. But on its own, it cannot go towards left, no matter how high value how high the coefficient of friction is. All right, is it okay, students? Is the problem okay? Kashini, Likita, Gayatri.
Yes, sir.
Okay. Now let us just. All right, we'll do one thing. Tomorrow we'll have only problem session. Today we'll complete the block on block concept. So in that problem session, we'll do tricky problems. So tomorrow we'll have only problem session. Today we'll try to complete the block on block concept. Now look at this. I've got a block of 10 kg kept on another block of mass 10 kg. So this is 10 kg. This is 10 kg. And a force of 15 Newton is applied on the upper block. And surface is smooth, mu is equal to 0, but surface between the blocks is having mu of half, 0.5. All right. So there is friction between these two surfaces, but the friction between this lower block and the ground is 0. So it is smooth. So what happens now? Let's understand what happens. We have to determine the acceleration of the blocks. All right, that's what you have to determine. But let's understand what will happen eventually. Because there is friction between the blocks, if the friction is less than limiting, let us say they are moving together. Okay, I don't know whether they are moving together or not, but let us presume they are moving together. In that case, I can treat this as 20 kg block under the action of 15 Newton. So the acceleration of the blocks, if at all they are moving together, this is if scenario, all right? If they are moving together, my acceleration of the blocks is 5 by 2, 50 by 20, which is 2.5, 2.5 meters per second square. All right, that's the acceleration of the blocks. But for them to move with this acceleration, what is the responsible force on lower block? The only force which can move it towards right is friction. So friction on the lower block has to be towards right. So friction, a reaction of that on the upper block will be towards left, right? Or I can think of it this way. If they are moving together, the friction between these two surfaces is static. And how do I decide static friction? I presume the surfaces are smooth. So if the surface is smooth, this tends to move towards right, friction will be towards left. Its reaction on the lower block is towards right. But a better reasoning is, because the blocks are moving towards right, lower block has only one force on it, which is friction, which can be responsible for its motion towards right. So friction on the lower block has to be towards right. So if I draw the FBD of the if I choose a ground frame and draw the FBD of the lower block, I'll have friction this way towards right. Why is it towards right? Because acceleration is towards right. And the only possible force responsible for which can cause this acceleration is friction. So friction has to be towards right. All right, understand this point. Acceleration of the system is towards right. Both the blocks are moving together. If they are moving together towards right, they'll move with an acceleration of 2.5 meters per second. So why? But then, if I just consider the lower block, its acceleration is towards right. So only possible force is friction. So friction for friction to produce an acceleration towards right, friction should be towards right. So friction is towards right. Its reaction on the upper block is towards left. Left. This is 50 Newton. This is F. Now let us see what amount of friction is required to produce 2.5 acceleration, 2.5 meters per second square. So F is equal to 10 times mass into acceleration, m into 2.5, which is 25 Newton. So friction required is 25 Newton. But what is the limiting value of the friction between the surfaces? It is mu times 10G. Mu times mu n actually. So normal reaction over here is 10G. So mu times 10G is mu to 100, which is 50. So limiting value of friction FL is 50 Newton. Required is only 25 Newton. So my friction can self-adjust so as to produce this acceleration 2.5. That means they will move together. So I presume whether they will move together. This is a presumption. All right, this is an assumption. I got an acceleration of 2.5 meters per second square for them to move together. Then I found out whether my friction is sufficient enough for me to produce this acceleration. Because only possible force on the lower block is friction. I'll see whether friction is sufficient enough for me to produce this acceleration. And friction required for that is 25 Newton, which is less than the limiting value. So my friction is sufficient for me to produce an acceleration of 2.5 meters per second square. That means my friction is sufficient enough for them to move together. All right. Is it okay? So I have presumed first they are moving together. Then I found out the acceleration. There is a strategy. All right. You will eventually understand the reasons behind strategy. I mean, intuitive reasons behind strategy if you solve many problems. We will solve problems eventually. Tomorrow, there's going to be a problem section only. But today, there's a strategy on how to attack a block and block problem. If they're moving together, acceleration is this much. I will check whether on lower block, on the second block, is my friction sufficient to produce this acceleration. All right, I can select any one of the blocks, but I'm selecting the lower block because only friction is involved in that. I can select the upper block also. I can write 50 minus F is equal to 10 times 2.5. So F is equal to 25. I got F as 25 whether from here or from here. I got the same as 25. But now 25 is less than the limiting. Limiting is mu n, which is 50 Newton. All right. So I got friction to be less than limiting. That means my friction will self-adjust to the value of 25. and produce an acceleration of 2.5 meter per second square. So they'll move together. So if they move together, this is the scenario. So F turned out to be less than limiting. So yes, they will move together. All right. So do they move together? Yes, they move together. Now let's look at a second scenario where I have to find out what is the maximum force for which they move together. All right. 15 Newton, for 15 Newton, they are moving together. But for 51, will they move together? They will move together as long as my friction is less than limiting. If friction crosses this limiting value, the lower block has a fixed acceleration, whereas the upper block has a different acceleration, they'll separate. All right. So friction is deciding, limiting value for the friction is deciding whether the blocks will move or not. So limiting, and that limiting value will decide the acceleration of the lower block. So for to determine whether the particles, what is the maximum force on the particle block A or the upper block A, block B. All right. I'm thinking of something else. Sorry. All right. Yeah. So this is smooth anyway. So friction limiting is 50. So if 50 is reached, what is the action of the lower block? 50 by 10. Action of the lower block is AL is 5 meters per second square. So my friction can produce a value of 5 meters per second square. So for them to move together, my external force should be sufficient enough to produce this 5 meters per second square. So if I say F is equal to 20 times 5 meters per second square. Why am I treating as 20? Because they are moving together. So I'll treat this as one block. So 100 Newton is the force for which they'll move together. I mean, that's the maximum limit of applied force for which they'll move together. So 50, 51, 52, so on. Or any value between 50 and 100, blocks will move together. But why are they moving together for a given range? Because I've got a range of friction. My friction is less than limiting. As long as my friction is less than limiting, they'll move together. Once friction reaches the limiting value, they'll separate. All right, is it okay? Tomorrow we'll do all Neet based questions also. So don't worry. We'll do Neet based questions and also IT based questions. And if at all I get a chance in the evening class, there is only MPC batch. That time I'll do purely IT based questions, IT oriented questions, IT aspirants oriented questions. All right, IT mains and advanced. But right now, concept is similar. Concept is same for both. So this is common for both. All right. So now let's look at the next problem where applied force is 101, or let's say it's 120. Anything more than 100, we'll separate. Should I make it 101 or 120? 120. 100 is easier to calculate. Okay, now what happens? Lower block is moving with a constant acceleration, I mean fixed acceleration of 5 meters per second square because F is reached, F limiting is reached. Friction has reached the limiting value, which is 50 Newton. So acceleration of the lower block now is, they separate. Acceleration of the lower block now is 5 meters per second square. And the acceleration of the upper block would be 120. FBD of the upper block is 120 and 50. And acceleration is A, let's say. So 120 minus 50 is equal to 10 times A. So A is equal to 70 by 10, which is 7 meters per second square. So lower block goes with the acceleration of 5 meters per second square, upper block goes with the acceleration of 7 meters per second square. So as long as they're moving together, I mean, as long as the force applied is less than 100, they move together with an acceleration of whatever F is. F, depending on whatever F is. F by 20 is my acceleration, common acceleration, AC. But once F is greater than 100, any value more than 100, the blocks will separate because my friction between the blocks has reached a limiting value. Friction between the blocks, as long as that is less than the limiting value, it can self-adjust. so as to produce an acceleration A, which is a common acceleration A, which is F by 20. But if that friction is reached the limiting value, it cannot further increase the acceleration than that. It cannot further increase the acceleration than a particular limit, which is 50 by 10, 5 meters per second square. So lower block at max can go with an acceleration of 5 meters per second square. But upper block depends on F. Lower block depends on acceleration of lower block depends only on friction, static friction between the blocks, which is self-adjusting. Now look at this. I got 7 acceleration of the upper block is greater than lower block. Lower block. Now if I increase it to 150, what happens? What is the acceleration of the lower block? It is 6, 5. But upper block's acceleration now is 150 minus 50 by 10. That is 100 by 10, which is 10 meters per second square. Or if I make it 200, it will further increase, but the lower block's acceleration is fixed. Do you understand this? Or you want me to repeat this argument? In the first case, when I had 50 Newton force, both were moving together. They were moving together because friction between them was static and friction was less than the limiting value. So friction reaches the limiting value, acceleration of the lower block reaches the limiting value. All right, beyond which it cannot increase. But upper block's acceleration can increase if I increase F. So if F is increased to 100 Newton, it is found that they are just on the verge of separating because friction between the blocks reaches a limiting value. All right. Okay. Now, let's apply a force of 60 Newton, but on different masses. Let the masses, over here the masses were same 10 kg and 10 kg. But now let's say I've got a 10 kg block and then 20 kg block. And the force applied is 60 Newton. So how do I do? And the question now is the friction, coefficient of friction is again 0.5. I have to find the acceleration of the blocks A and B. First of all, I have to determine whether they'll move with same acceleration or not. For which I have to determine whether the friction between the blocks has reached a limiting value or not. For which I have to presume whether that the blocks are moving together and check whether the friction between them, for them to move together, has reached a limiting value. I've got the upper block like this, presuming they move together. So acceleration of the blocks would be 60, 10, 20. So the total is 30. 60 by 30 is my 2 meters per second square is my acceleration, common acceleration, AC. If at all they move together, I don't know still. But if at all they move together, their common acceleration is 2 meters per second square. But what is the force responsible for motion of B towards right with acceleration of 2 meters per second square? Friction. So it is friction which is causing an acceleration of 2 meters per second square, if at all they are moving together. So how much friction is required for that common acceleration? I draw the FBD of the lower block. Friction is towards right. So friction is equal to 20 times 2, which is 40 Newton. Now I have to check whether this has crossed the limit or less than the limit. If this is less than the friction limit of the limiting value of the friction, they'll move together because my friction is self-adjust so as to produce this acceleration. But if this friction has crossed the limiting value, then they'll separate. Then I have to solve the problem again, taking the limiting value as a force. So what is the limiting value of the friction here? 50 Newton. Half times n, mu times n, where n is 100. So half times 100 is 50. So this is less than 50, so that means they move together. So acceleration of the blocks A and B is 2 meters per second square, and the friction between the blocks is static, which is 40 Newton. The moment they separate, the friction is kinetic. All right. As long as they move together, the friction is static because relative motion between the surfaces, relative motion between the blocks will decide whether the friction is static or kinetic. If there is no relative motion at all, the friction is static. If there is relative motion, the friction is kinetic. All right. Okay, now let us again find out the maximum force required for them to move together. So maximum force, let that be F. But when that reaches maximum, what I mean by maximum force for them to move together, that means lower block has reached a maximum possible acceleration. And what is responsible for that maximum possible acceleration? Limiting value of the friction, which is 50. So F is equal to 10 times, sorry, this is, yeah, 20. F is equal to 20 times A. So A is equal to 2.5 meter per second square, because F is 50, FL. Now maximum possible acceleration is 2.5 for them to separate. So beyond this 2.5, lower block cannot produce an acceleration more than 2.5. So for them to move together, my combined system should move with an acceleration of 2.5. So common acceleration is 2.5. So I'll have F is equal to 30 times 2.5, which is 75 Newton. So maximum possible force for them to move together is 75 Newton. And that means anything between 50, 51, or any force less than 75, all right, any force less than 75, the blocks will move together. And will they move first of all? Yes, they will move because the surface is smooth. If the surface were rough, then I would require a minimum force also, because I have to start the blocks. I have to start the block, lower block, or on the surface. Or the scenario is different, or the strategy is different. But when there is a frictionless surface and the surface between the blocks is frictional, then there is a strategy. All right, you will understand the intuitive reasoning behind the strategy with practice. All right, which is very important. All right, see, you will not be able to think the way I am thinking now, looking at the blocks. If you do just one or two problems, you will have to do at least 10 problems so as to understand what is happening when you write equations behind the scenes, what is happening. All right. All right. Let's go for the next one. Okay. Now let's say force is applied on the lower block instead of the upper block, and let's say this is M1 or M naught and M naught. All right. All right. For convenience, I'm taking M naught, M naught. We'll go for M1 and M2 later, or you can try for M1 and M2. But let us say they are M naught and M naught. Now what happens if they move together? Net acceleration is F by 2 M naught, which is common acceleration AC. F by 2 M naught. But then what is responsible for the motion of the upper block? It is friction. If friction is responsible for the motion of the upper block, and the upper block is moving towards right, friction on the upper block has to be towards right. If that is not towards right, friction on the lower block has to be towards left. Its reaction will be towards left. Always when you think of a force, think of its reaction as well. If friction is towards right, which is action, its reaction is towards left. On the lower block, again, action reaction pair always act on two different bodies, two different blocks here. All right. Action reaction do not act on the same body. Action reaction act on the two separate bodies, which is causing the acceleration action reaction. See, this friction between the surface on the upper block is towards right. Its reaction is on the lower surface, which is towards left. All right. So now what is the value of friction there? F is equal to M naught into F by 2 M naught, and let the coefficient of friction be mu, which is equal to F naught by 2. Now F naught by 2 is less than the limiting value. That is, if F naught by 2 is less than or equal to limiting value, which is mu m naught g, then they'll move together. That means F should be less than or equal to 2 mu m naught g. All right, I'm doing the same thing. If they move together, I've got a common acceleration. The only possible force on the upper block is friction, which is in the direction of common acceleration, which is towards right. So friction on the lower block is towards left. If I write the FBD of the upper block, friction is equal to mass into acceleration. Assuming they are moving together, I'll get F by 2 as the friction. If F by 2 is the friction, if this friction is less than the limiting value, then they'll move together. That means F by 2 should be less than or equal to mu mg. So F by 2 is less than mu mg means F is less than 2 mu mg. So as long as the force is less than 2 mu mg, from 0 to 2 mu mg, the blocks will move together. Once it is greater than 2 mu mg, my friction will reach a limiting value, which is mu mg, and the blocks will separate. If the friction is mu mg, the acceleration of the upper block would be mu mg by m. Acceleration of the upper block will be mu mg by m, which is mu g. So maximum acceleration of the upper block is mu g, beyond which they separate. So if the body together they are moving with an acceleration of mu g, the blocks are tending to on the verge of slipping. On upper block is on the verge of slipping on the lower block. Anything more than mu mg 0.1 as well, or anything little more delta more than mu mg, they will definitely separate. And why is it separating? Because my friction is not sufficient enough to support that acceleration, support and create that acceleration, produce that acceleration. All right, that common acceleration. All right, I hope that is clear. All right. Now let us do one thing. So, any doubt so far? You want me to repeat any scenario? Previous scenario or this scenario? You want me to repeat any scenario, students? What Namneet, Navneet, Mani, Likita, Abu Sofyan, and Hashni. You want me to repeat any scenario? If you want to repeat everything, I can repeat because it's very important concept. Block on block is a very important concept and a little tricky as well. I mean, you have to understand the
Last
strategy.
one, sir. Last one.
Sorry,
Last one, explain, sir.
this one? Okay, I'll explain. I've got a block, two blocks, M0 and M0. Applied force is F0 on the lower block. All right. Till now we have applied it on the upper block, but now I'm applying it on the lower block. All right. Now what happens? I have to determine the acceleration of the blocks and the maximum value of F0 for which they move together. All right. If at all they are moving together, I have to determine the acceleration of the blocks. And if at all they separate, and what is the maximum value of F0 for them to move together? And if they separate, with what accelerations will they move? All right. That's the scenario. That's the question. Now the scenario is, presuming they move together, they'll have a common acceleration of F by 2 M0. Is it okay? Is this okay? Now to produce this acceleration, the upper block, it's only friction which is responsible for to produce this acceleration. Friction will be acting towards left on the upper block and towards friction will be acting towards right on the upper block and towards left on the lower block. So friction F on the upper block is how much? mass times acceleration, assuming they are moving together. So I'll have F naught by 2. Now, if F naught by 2 reaches a limit, they'll move together as long as this is less than mu m naught g. That means as long as F naught is less than or equal to 2 mu m naught g, the blocks will move together. The moment it is greater than this, any value delta greater than this, even if it's very infinitesimal amount greater than this, they will separate. When this is F naught is equal to 2 mu m g, they are on the verge of separating. Alright, upper block is on the verge of slipping on the lower block, over the lower block. Alright, now, assuming F naught is greater than 2 mu m g. Now what happens? They'll separate for sure, right? That means on the upper block, limiting value is reached, which is mu m naught g. So acceleration will be force by mass, mu m naught g by m naught. So acceleration will be mu g. Acceleration of the upper block is mu g. So acceleration of the lower block will be f naught minus mu m naught g is equal to m naught into acceleration of the lower block. So I'll have acceleration of the lower block as f naught minus mu m naught g by m naught, which is equal to f by m naught minus mu g. Is it okay now, Navneet? We've gone a step
Yes, sir.
ahead. We just found out the maximum value of the friction before, but we have not, maximum value of applied force before for them to move together. But now we have gone a step ahead and found out the acceleration of the upper block and lower block. Acceleration of the upper block when they separate is mu g. Acceleration of the lower block when they separate is f by m minus mu g. All right. But now, if I have to decide the friction, I can also decide from. I have to choose a reference frame first. For any NLM problem, I have to choose a reference frame. Newton's laws problem, I have to choose a reference frame. I can also choose the reference frame as my lower block, accelerated reference frame. If I stand on the lower block, on the surface on which I'm moving, I'll draw all the forces on the upper block, including the pseudo force, because lower block is accelerating with an acceleration, some acceleration A. So pseudo force will be acting towards left. To counterbalance that, my friction will be acting towards right. Because it has a tendency to slip towards left because of pseudo force, F pseudo. So it has a tendency to move towards left, but the friction acts on a, it has a tendency to move towards left, so static friction acts towards right. But from ground frame, how do I decide? The only possible force for it to produce an acceleration towards right is friction. So friction has to be towards right. But from this accelerated reference frame, how am I considering? It has a tendency to move towards left. Friction acts towards right. Why does it have a tendency to move towards left? Because pseudo force is acting towards left. And pseudo force is acting towards left because acceleration of the lower block of the reference frame on which I stand is towards right. Pseudo force acts towards left because pseudo force is always opposite in direction to the acceleration of the reference frame. All right. Okay. Now let us go for a even more general case where f is varying with kt. Now f was varying, but I had some limiting value, a range of values for which they move together, and beyond that range, beyond that value, limiting value, they will separate. And when they separate, acceleration of upper block is mu g, acceleration of the lower block is this. And we have decided the direction of friction logically. All right, now let the force be kt. So let the force be c times t. So force is varying with time. That means this force will at certain point of time, it will cross the limiting value of the force, after which they'll separate. All right. So as long as this force is less than the limiting value. So how do I do that? Just let that be F. So F minus on the upper block and the lower block, assuming they move together, my acceleration is C naught T by 2 m naught. Common acceleration is C naught T by 2 m naught. So if I plot a graph, I'll have a straight line passing through origin. Y is equal to mx. This is the common acceleration, AC. This is the acceleration of the blocks, and this is the common acceleration with which they move. But then, the moment this crosses the limiting value, that is C naught T is greater than or equal to, sorry, greater than 2 mu m naught G. That means T is equal to 2 mu m naught G by C naught. At that value T naught, they'll separate. Once they separate, the upper block moves with an acceleration of limiting value is mu m naught G. So acceleration will be mu m naught G by m, which is mu G. And that goes with the constant acceleration. So acceleration of the upper block is constant now. AU is constant. Now let us find the acceleration of the lower block. Acceleration of the lower block now is C naught T minus mu mg is equal to m naught into upper acceleration of the lower block. So acceleration of the lower block is equal to C naught T by m naught minus mu g. Now look at this. This is C naught T by 2 m naught. This is C naught T by m naught. The slope over here is double the slope over here. If the slope is this much, I'll have a slope double of this one, so that will be even more steeper. So acceleration of the lower block will have, and it's y is equal to mx plus c, right? Y is equal to mx plus c, which is negative constant. So it's pulled down. So I have got line like this, double the slope of AC, and it's pulled down by mu g. So I'll have an slope something like this. All right. So that's the acceleration of the lower block with time. As time passes, acceleration they have a common acceleration till time t naught. After that, the blocks separate. Upper block goes with the constant acceleration mu g, and lower block goes with the increasing acceleration, increasing with time. The moment they separate, and at this moment they separate. At t naught they separate. And what is t naught? I got t naught as C naught T T naught as 2 mu m naught G by C naught. That's the value of T naught I got. At this time they separate. After they separate, acceleration of the upper block is constant and acceleration of the lower block is increasing with time. Now let's understand this intuitively. See, initially, let's say the force is very small and the limiting friction over here is quite a bit. All right. So this can self-adjust to produce an acceleration, common acceleration, AC. Now, as this force goes on increasing, acceleration of m goes on increasing linearly, but because friction is less than limiting, it can cause the same acceleration of the upper block, so they can move together to a certain value. But once they separate, upper block has got a force which is constant, limiting value, mu m naught g itself. Now, beyond which upper block will now move with a constant acceleration because it has got a constant force on it. But lower block has got a variable force on it. and that variable force is dependent on t linearly. So I'll have a linear acceleration versus t graph to be linear. And that force would be, that function would be F minus friction, which is limiting, which is constant. F minus limiting friction by total masses by acceleration. I'll get the equation of the line. See, again, I told you, before we plot the graph, we need to get the characteristics of the graph, characteristic properties of the graph. Only then we can plot. Here we got it to be linear, right? Then I plotted that linear graph. Here I got it to be constant, so I just put a constant value. Here I got it to be linear with more slope than AC. Then I plotted that with this graph, with that line. Is this problem okay, students? If it is okay, we'll go with different masses now, M1 and M2. So what is happening here? Till time reaches this value, friction doesn't reach its limiting value. So friction is enough for it to produce an acceleration, common acceleration AC, the acceleration which is produced presuming they move together, which is AC. Now limiting, if the friction is less than limiting, it can go with a common acceleration AC, and the friction will reach a limiting value at this time. Once it reaches the limiting value at this time, the blocks will separate. Upper block goes with an acceleration of mu g, and lower block goes with an acceleration of an, which is Ct minus mu mg is equal to m into a. But how do I get this equation? It's simple. Net force is equal to mass into acceleration. To write this net force, I choose the reference frame, and I draw the FBD of the block. And FBD of block is simple. F minus friction is equal to mass into acceleration. So F is C naught T minus friction, which is mu m naught g mu into n. N is m naught g here, is equal to mass into acceleration. All right, so I get force is equal to mass into acceleration, I get acceleration from there. So see, what all I'm doing is I'm just using a reference frame, drawing FBD, picturing the FBD, not drawing literally, but I'm picturing the FBD, then writing the F is equal to ma equation to get the accelerations. The only crux of the problem is understanding that I presume them to move together first, and I check whether the friction over there, which is limiting, which is static, has reached the limiting value or not. Because limiting friction is friction which can produce the maximum possible acceleration of the upper block, which is mu g. As long as the friction is less than the limiting value, they'll move together. Once the friction reaches the limiting value, friction between the surfaces cannot produce greater acceleration than mu g, but lower block is going with greater acceleration than mu g because its function force is depending on t. All right, so let's now try with M1 and M2. I hope this is clear. If just take a snapshot of this one, otherwise you can analyze it later. Right, let's go with M1 and M2. I'll just initiate the process. You try to solve the whole problem. That is again varying as CT. And I've got M1 here, M2 here. So what is the limiting value of the friction now? Mu times N, where N is M1G, right? This is N, this is M1G. So N is equal to M1G. So mu into N, mu M1G is the limiting value of the friction. We have seen as long as F, which is CT, they're moving together. As long as they're moving together, my common acceleration will be CT by M1 plus M2, which is common acceleration. Now, limiting value of the friction above, if it can produce this acceleration, which is M1 times this acceleration is the friction on the upper block. And this is less than or equal to mu M1G, they move together. So I got the condition for them to move together. So I'll get the time as well. So T is equal to mu M1G into M1 plus M2 by M1. So M1 gets cancelled out here. So it's mu G into M1 plus M2 by C naught. As the time at which they separate, T naught. Check if this is correct, students. Did I make any mistake here? But I don't think you have followed because. All right, this is a little complicated, I agree, students, but it will take some time for it to seep into your brain, but it will take some time. So I suggest that we'll stop here. We'll continue with M1 and M2 tomorrow, and we'll do some critical problems tomorrow for both Neet and JEE. All right, so let's do some problems at a. We'll go from basic problems to tough problems at a moderate pace, slower pace, moderate pace, and the quicker pace. All right, so tomorrow let's do only problems tomorrow. So with this, we have completed block on block, certain part of the block on block where force is applied on two blocks, lower block or upper block with the frictionless ground and friction between the surfaces of the blocks. Friction between those blocks. There is friction between the blocks, but friction on the surface is zero. All right, in such cases, we have done. What happens if friction is non-zero on the surface? We'll do it later. All right, you can think about it, but right now, let's not go into that. Till we master this one, let's not venture into something new. All right, that's it, students. Let's stop here. Hashini, Likita, Namani, have you understood today's class or was it very difficult?
Yes, sir.
Well, it was tricky, no? Like it was little difficult, not for today.
Yes, sir.
Okay. So if at all you have got any doubts, please ask me. All right, I'll clarify those doubts. Don't hesitate because ultimately your benefit, which is to be kept in mind. All right. I
Okay,
can
sir.
repeat. All right. I can repeat again and again. This is for everyone. All right. Thank you all, students. Have a great day. Bye, everyone.
Bye, sir.